trapezoids today. First, I want to point out that they are seen a lot in real life. If you look at the $1 bill, you'll notice this symbol has a truncated pyramid with an all-knowing eye above it, apparently. And this is a trapezoidal shape, the truncated pyramid. If you look at sports cars that have spoilers, a lot of times they'll have the way that they're attached to cars is with a trapezoidal shape. Sometimes even from the back they'll have some sort of trapezoidal shape. I've seen a few guitars in my life that have had sort of a trapezoidal shape to them, sort of the fronts. And this apparently gives it a specific sound different than normal acoustic guitars, but they'll have a trapezoidal shape to them. Pyramids, this is called a ziggurat in particular. It's an ancient form, a place where people would worship. Especially the Aztec people and other South American natives would actually worship at these ziggurats. Basically a building with stairways to heaven kind of is the idea here. You'll see the trapezoidal shape obviously in it. In architecture, a lot of times you'll see trapezoidal windows more often than you think. They're not just rectangular windows, but a lot of times you will see a few windows sometimes at the edges of buildings of the trapezoidal shape. And also a girl that's looked closely at her diamond ring will notice that most of the time, because of the circular shape to a ring, her diamond isn't just going to be sort of kite shaped or triangular in shape, but it'll sometimes have sort of a trapezoidal shape to go with it. We're going to look at trapezoids throughout this presentation today. I just want you to realize that they are in real life, they are around us, and because of the way that they're made and they're built architecturally, or sort of instrumentally, I guess, or just cut, we do need to know some of the properties of them because they do come up. So let's first off talk about some of the properties. Just in general, because a trapezoid is a quadrilateral, we know that there are 4 sides and 4 angles with every quadrilateral. So we'll just say 4 sides and 4 angles are included. Additionally, when you talk about that, we could talk about the sum of the interior angles. The sum of the interior angles being 360 degrees because it is a quadrilateral. And thirdly, we need to talk about the base. This is a base on a trapezoid here. This is the other base. These are the 2 sides that are actually going to be parallel in every single trapezoid. So we'll say the bases are parallel. The bases are parallel. When we look at a special type of trapezoid, the isosceles trapezoid, and it has to tell us in some way that it is an isosceles trapezoid, we'll notice quite a few things. For one thing, the base angles are congruent. The base angles are congruent. So if I was to do these, the base angles are the ones that are near the base. So this angle will be congruent to this entire angle. But there's also this base down here, so these angles are also going to be congruent to these angles down here. So there's actually 2 pairs of congruent pieces. Another interesting idea is that the consecutive angles between the bases are not congruent, but they're supplementary. So how do you talk about this? If this was 40 degrees down here, this angle would obviously over here would also have to be 40 degrees, but consecutive on the sides would be these 2 angles. So these 2 angles have to add up to 180 degrees, so this one has to be 40. 140 and 40 make up 180, and this one over here would also have to be 140 degrees. So these 2 angles along the side and these 2 angles are always going to be supplementary angles. Consecutive angles along the side are supplementary. The legs are also congruent. So we talked about how the bases are parallel, but the legs, which are over here, these are also congruent. We'll just call those, these are the legs of a trapezoid, the legs of a trapezoid. And finally, if we were to draw these, we talk about the diagonals. So the diagonals are congruent. So if we were to draw some diagonals into one of these, this was an isosceles trapezoid, this diagonal would be congruent, same length as this diagonal, like so. So as we talked about, we have a base that's parallel to this other base. If this was an isosceles trapezoid over here, this side would be congruent to this side, this angle congruent to this angle congruent to the other base angle on top, and these angles here and here are going to be supplementary, these 2 angles here are going to be supplementary. Quite a few things to kind of keep in mind and to keep moving as far as we talk about trapezoids. Just keep all these things in mind these several properties. And what happens is these properties apply to all trapezoids, so both trapezoids and isosceles trapezoids, and these properties are just specific for isosceles trapezoids. So we don't have to talk about base angles being congruent over here, or consecutive angles being supplementary, or the legs being congruent, or the diagonals being congruent. That only happens when we talk about isosceles trapezoids. So don't try mixing them up. We'll have to be told in some way that this is an isosceles trapezoid in order to make use of these properties. Trapezoid is actually found on the, I think this is the Kuwait flag. The Kuwait flag. They actually have a black trapezoid. Probably has some sort of meaning, but it also links together each of these other three colors. Flags are usually really interesting to think about and to talk about how people formed and figured out why their flags are the way they are. Let's talk about these properties really quickly. The consecutive angles between the bases of a trapezoid. Remember, those are going to be supplementary angles. Supplementary angles. That means that they're going to add up or sum to 180 degrees. Isosceles trapezoid conjecture, the base angles of an isosceles trapezoid. The base angles, remember, those are going to be congruent. And the isosceles trapezoid diagonals conjecture, the diagonals of an isosceles trapezoid, those are also going to be congruent. This is sort of a medical symbol. There's a snake wrapped around this. And this is on probably some sort of medical piece of equipment, probably for a pretty tough truck. Architecturally, if you look at some Native Americans and South Americans, this is sort of a pretty easy structure to build, but it is a truncated pyramid shape or a trapezoidal shape on the front. Let's look at some examples as we go along. If we look at these two angles, 128 and y are both base angles, so we know that y is going to be congruent to 128, so it'll also be 128. And then additionally, if this angle right here would also be x plus 128, those two have to add together to be 180 degrees. So if I subtract 128 from both sides, I'm simply going to get that x is 52 degrees. So there's my x, there's my y. I'll put the 52 up here just in case as well. For the second thing, we're looking at, again, the perimeter. The perimeter of this shape is going to be 85. So I'll say 85 equals, I'll say that's 37 plus 18 plus x plus x. Remember, the x's are the two legs of the trapezoid. When I add these together, combined like terms, I'd have 2x plus 55 equals 85. When I subtract 55 from both sides, I would have 2x equals 30, where that x equals 15. So each of these lengths of the legs are going to be 15 centimeters long. We can talk about architecturally. This is sort of a keystone shape or a trapezoidal shape. Keystone. Keystones are really important when you're building arcs over things. The keystone is actually what holds a lot of the weight. These two people are actually standing in a doorway with a keystone shape or a trapezoidal shape. Additionally, if you've ever used a razor blade or had to replace a razor blade, this is the really sharp edge right down here, but they actually make them in a trapezoidal shape. It actually holds weight really well, as strong as a triangle, but you can kind of truncate the triangle, so you have these things to sort of keep the friction and also be able to sort of gear these things up or down. Again, we're talking about perimeter. Perimeter for this one is going to be 164 degrees. I'm sorry, 164. We have to add up the four sides. Well, one side is going to be y plus 12. That's this leg here. And this side also will be y plus 12. So we'll have to add two of those on there, two y plus 12s. Our top, sort of this base here, is going to be y minus 12. And lastly, our last base over here, this is going to be y. We're going to combine terms, and that's going to be quite a bit of work here. We have 1, 2, 3, 4 y's, so we have 4y. And then we have 12 plus 12 is 24, minus 12 is back down to 12. So we'll say 4y plus 12 equals 164. We'll subtract 12 from both sides, and we'll be at 100. I'm sorry, we'll be at we'll be at approximately 152. I'm sorry, 152. 152 equals 4y. When we divide both sides by 4, we'll just have y equal 152 divided by 4. 152 divided by 4 gives us a nice number of 38. So this is y equals 38. We're going to solve for x. X is up here. Oh, this would tell us that this side right here is 38. If we add 12 to this would be 50. This side would also be 50. When we take 38 minus 12, this would be 26 centimeters. So this side is 26. The opposite base is 38. This side's 50. This side's 50. Sometimes it mixes students up when the bases are not on the top and bottom. The bases can be on the right and left side just as easily, and the legs be on the top and bottom. You just have to realize what sides are the same and what sides are parallel. The parallel sides are always going to be the bases. Last, we have to solve for x. X, since these are the base angles, both of these angles are going to be x. Since this is 81 degrees right here, these two angles need to be supplementary, so we'll say x plus 81 has to equal 180. If I subtract 81 from both sides, I'll just have 99, so x will be 99. Depending on your perspective on a building, this office building actually has a trapezoidal shape. These are the clouds, obviously, in the sky. Obviously, the building is not built like that, but it does have the perspective of being this way. Additionally, this bookshelf, which looks really funky, has a trapezoidal shape, depending on its based on your angle and your perspective. Number 4 says use the diagram at the right for each of the 3 parts. It says part A says that BD equals 15 yards, so that's this diagonal, BD equals 15. So it asks about AC. AC would also have to be 15 yards. Make sure to have your units included here. AB, which is the left leg, is 8 inches, so that means DC also has to be 8 inches. It says then if angle DBA equals 50, so let's see, this is D to A to B, that's this bottom base angle. Then I need to be talking about angle DBC, ADC would also be 50 degrees. There's probably a little typo on this one. It's 50 degrees. Angle ABC, since these two angles have to be supplementary, I'll say it's 130 degrees. And then finally, the measure of angle DCB also has to be 130 degrees. Kind of a morbid thought, but maybe the last trapezoid you'll experience might be in the form of a casket here. I'm a huge fan of popcorn, and the popcorn tin that I have at home actually has a trapezoidal shape as well. I had to point that out to you guys. Because 56 and Y are base angles, we'll say that that's also 56 degrees. Since 56 and X have to be supplementary, we'll say that's 124 degrees. So X equals 124, Y has to equal 56. Last problem, we actually have a kite sitting right on top of a trapezoid. This is kind of a precarious spot for a kite to be. But remember, with a kite, the two non-vertex angles are going to be congruent. So this makes this angle 137, and this angle down here also 137. Since 137 and Y have to be supplementary, we'll say 180 has to equal Y plus 137. We'll subtract 137 from both sides, and Y is going to equal 43. In order to figure out the measure of X, we have to sum together the interior angles of this kite. Remember, the interior angles of any quadrilateral, including a kite, are going to equal 360 degrees. So we'll say 137 plus 137 plus 22 plus Y. When you sum these together, you'll get X plus 296 equals 360 degrees. You subtract 296 from both sides, and X should equal 64 or 64 degrees. 64 here, and Y would be 43. Just make sure they're on the line. Trapezoids are frickin' awesome.